Ladies and gentlemen, boys and girls, children of all ages, you received this paper back. Now this one up on the board is a little more difficult to read, so I will probably be reading it with you. But the first question, these are the finishing times in a race. Write the finishing times in order from fastest to slowest. Compare the times using these symbols. The blanks, I had people come up to me and say, I don't get it. Well, it tells you to write a time there, a symbol there, a time there, a symbol there, and a time there. They give you the 3 times to write down. They tell you what symbols you're going to use. So, I don't get it. It's confusing to me when you say I don't get it. In addition, I said in a race, the fastest time is the smallest number. When comparing and ordering decimals, we always, and I mean always, write them down, lining up the place values first. And when I look at papers and they miss it, and they don't do the way I've taught them, and they miss it, and then they're like, why did I miss it? And I'm going to say, because you didn't follow directions. And what directions? I'm going to say, because you didn't write them down, line up the decimal point. And then they're going to say, I'm so sad. I'm going to say, I'm not. I'm glad you missed it because it proves my point that you need to do it the way I say to do it. So this is the paper you did Friday that we're going over. But one of the questions from today, the first question from today, tells you you have to compare the decimals. Now, they don't go the same distance. This one goes to the hundredths, tenths, and tenths. Now, if I put a 0 in the hundredths, that doesn't change the value. $23.05, because the 5 is in the tenths place, plus 0 pennies doesn't change the value. Still $23.50. If they go out to the hundredths place, I like to imagine that it's money. It makes it easier for me. Mr. McMurdo told you that a race you'd use the smallest number first. Landon, which of these 3 numbers is the smallest?
12.
What?
12 and 5.
That's not even on here.
Not mine.
No, it's not. Because we're going over the paper from Friday, like I said.
Oh.
I'm sorry, Mr. McMurdo, I really haven't been paying attention until you called on me.
But it's 23.
And what? 23 and 1/10. Or 23 and 10 hundredths. So that should be your first one. 23 and 1/10, which is less than. So we've done this first product. I put my number in, I put my symbol in. Hopefully you're following along with the paper from last week. So you can see if you got these correct. The next one, Miss Layla. What is the next smallest number of the 2 that are left?
23 and 5. 10.
No. Think of it as money. $23.15, $23.50.
Then 23 and 15.
Good. 23 and 15 hundredths. And that is smaller than, we've used this. Connor, can you tell me which one's the biggest?
2/3 and
Not 2/3.
23
And
5.
tenths. 23 and 5/10. But do not ask me how to compare decimals if you're not going to line them up by place value. If you're not going to put any zeros in there that you need to put in to make them the same distance behind the decimal point. That'll make me cray-cray. Now I already did number 2, and I showed you the video on number 2. So keep recording. I'm going to go up. We're going to look at a couple of these. Stay on my way, chair. We go up and we're going to look at a couple other ones here. As soon as I find my mouse, there we go. We did number 3 in class. you should have that right, although most of you didn't do it right. I mean, some of you had the area of the base as crazy numbers, and I told you to multiply 17 times 15. Should have gotten 255. So if you didn't get 255 on this, you're crazy loco. Number 4 tells us we don't even have to look at the picture. The expression 4 times 1 6/10 is shown in the model below. What is the product? It tells you what to do.
4 times
1 6/10
times 4.
times 4. When I am multiplying with decimals, I'm going to ignore the decimal point when I'm doing the math. I'm going to ignore it. Otherwise, it's going to confuse me to no end. You do not, and the rock means do not, put the decimal point in when you're doing the multiplication, because it'll just make you cray-cray. 4 times 6 is, good, 24. Carry my 2. 4 times 1 is 4, plus 2 is 6. Now, I go back to my problem, and I see there is one number behind the decimal point in the problem. There needs to be one number behind it in the answer. So you should have gotten 6 and 4/10.
I got 6.4.
Now, if you got it wrong, you probably didn't do the work. Would be my guess.
I did the work, but like a noob. I did like a noob.
All right, this problem. Mrs. Lewis ordered a set of 18 shapes. So here are 18 shapes. They even gave us the pictures of the 18 shapes. She put 2/3 of the new shapes to build a structure. She's going to use 2 out of every 3 shapes. 2/3 of them. So is she going to use all of the shapes? No. The word of tells us we're going to multiply. So 2/3 of 18, or 2/3 times 18. Now when they give you pictures, this tells you how many we have. This tells you how many groups we need. We need 3 groups. This problem already nicely divided it into 3 groups. 1 group, 2 groups, 3 groups. Already nicely divided it into 3 groups. But we just want to know how many of them are in 2 groups. And then all we'd have to do is count. I don't care if you use your fingers or toes or boogers. Well, I don't know. You can pick a booger every shape, and then you can count the boogers. I don't know. So how many shapes?
12.
18.
No, 12.
12. 2, 4, 6. The total of shapes is 18.
12.
Oh.
12. There's a total of 18, but there are 12 circled. There's a total of 18, but there are 12 circled. Now, if you use the standard algorithm, which you could have done, I'd make 18 as a fraction, 18 over 1. I'd multiply straight across. 2 times 18 is 36. 3 times 1 is 3. Improper fraction. I divide 3 into 36. And once again, I get 12 no matter which way I do it. But if I'm doing it, and they show me the picture, just divide that many pieces into that many groups and count how many are in that many groups. All right, so let's look at another one. Addie's, your arm getting tired? Good.
Nice. We're going to do this for 30 hours.
Good, good.
That is
Move down to the next problem here.
Tanny.
All right, so Tammy wants to buy a bike. She's saving money. In 5 weeks, when she buys the bike, she needs to have $96.30. She doesn't have any right now. But she's got to make money every single week in order to buy this bike. How many weeks does she have to make this money?
Every single week.
How many weeks? 5.
What?
Every single is not how many.
But you said every single week.
Okay? So she has 5 weeks. She's going to save the same amount of money each week. So that means we're going to do what?
Multiply or division.
Well, you can't be both.
Okay,
Well,
multiply.
you can only divide.
You're going to divide. Because if I multiply, that's telling me she's going to save more than $96 per week. Which makes no sense if she only has to have $96.30. The amount per week is going to be less than $96.30. The only way you all know right now know how to get a number and make it smaller is dividing or subtracting. So we're going to multiply or divide $96.30 divided by 5. The amount of money she needs divided by the amount of weeks she has to save it. When dividing with decimals, my decimal point comes straight up. Just move it straight up. Does 5 go into 9? Yes or no?
Yes.
I'm going to have a 2-digit dollar amount and a 2-digit change amount. How many times does 5 go into 9?
1.
1. That eliminates this answer and this answer right away. Then I multiply 1 times 5. It's 5. Subtract. I get 4. Bring it down to 6. How many times does 5 go into 46? 9. That does not eliminate any answers because these both have a 9 in the ones place. And 9 times 5 is 45. I subtract. I get 1. I bring down to 3. How many times does 5 go into 13? 2. And that eliminates this answer. I don't even have to finish. I know it's got to be that answer.
Yay.
Now, Arian wants to check his work. The inverse operation for division is multiplication. So he could take $19.26 and multiply it by 5. And if he did his math right, what should he get? $96.30. Is that the last one?
I did that. Look.
Is that the last one? Hello, anybody paying attention?
Yes,
All right.
the right one.
All right.
Oh.
Boom! Shakalaka, peace out. God bless. Love you. Do something kind today. Save the bees. Thank you.